Hello dear class 10 students, I hope everyone is studying. So welcome to lesson number 2 of the chapter Metals and Non-Metals. So guys, in this module we will continue the other two physical properties of metals and non-metals. They are color and malleability. Alright, now let us see the color of metals. Most metals are white or silvery grey. Now if you can observe, you can see that most of the metals, they are white or silvery grey. Alright. But again, there are exceptions. So exceptions are gold is yellow and copper is reddish brown. Now most of the metals they are either white or silvery grey, but the exceptions are gold and copper because they are gold appear in yellow and copper, as you can see, it is reddish brown. Alright. Now let us see malleability. Most metals can be beaten into thin sheets or foils. The property by virtue of which metals can be beaten into thin sheets is called malleability. Now see, malleability basically it is a property by virtue of which the metals they can be beaten into thin sheets or foils. So that property is called malleability. Clear everyone? Gold and silver are the most malleable metals known. This is what helps jewelry designers create intricately carved bangles, chains and decorative articles in gold and silver. Now see the two metals, gold and silver, they are the most malleable metals that is known. Now because of the property of malleability, the gold and silver, it helps the jewelry designers to create the intricately carved bangles, chains and also other decorative articles made from gold and silver. Now see, as you can see, for example, these gold chains. Now due to the property of malleability, it helps the jewelry designers to make these beautiful designs. As you can see here, in silver, so we basically use the silver foil on top of the sheets. Alright. Other metals that can be beaten into sheets include aluminium, iron, copper and tin. Now other metals are also there which can be beaten into thin sheets, include aluminium, iron, copper and tin. Now see, for example, this is an aluminium roofing. So basically we use it in our housing system, right? Now see the next example, iron. So these are iron rods. Now see the example of copper. So these are copper wires. Most of have seen it, right? Then say tin. So basically these are tins. So it is used mainly for the packaging of canes and all. Alright. Okay guys, now let us see the malleability for non-metals. Non-metals are brittle and cannot be beaten into sheets or foils. Now most of the non-metals, they are brittle. That means they are hard and they cannot be beaten into sheets or foils like the metals. Alright. Okay, now let us see one activity. So the aim of the activity is to show that metals are malleable and non-metals are brittle. So in this activity 1, our aim is to show that the metals they are malleable and the non-metals they are brittle or hard. Alright, now take a small iron nail. So this is a small iron nail. Alright, now beat the iron nail with a hammer. Okay, now start beating this iron nail with a hammer. So try to hit it hard, okay? Hit harder. Now as you can see that the iron nail flattened upon beating hard. So after beating hard, you can see that the iron nail it flattened upon beating hard. Alright, so we can say that the metals they are malleable because iron it is a metal. Clear everyone? Okay guys, now let us see the activity 2. So take the piece of thick aluminium sheet. Now this is an thick aluminium sheet. Okay. Now beat the aluminium sheet with a hammer. So similarly, start beating this aluminium sheet with a hammer. After that, you can see that this aluminium sheet flattened upon beating hard. So after beating hard, you can see that this aluminium sheet has been flattened. Alright. So thus we can say that metals are malleable because we have already got to know that aluminium which is a metal. Now let us see activity 3. Take piece of pencil lead made up of graphite. Now take a pencil lead which is made up of graphite. Okay. So basically the pencil lead, it is made up of graphite. Now beat the pencil lead with a hammer. So after beating the pencil lead with a hammer, you can see that the graphite, it has been broken into pieces. Alright, so as you can see here, the pencil lead powders on beating. So this pencil lead, it turned out to be powders on beating. Alright, now from here we can observe that the metal objects gets flattened upon hammering, while non-metals, they break. So from here we got to know that, or here from this activity we observe that all the metal objects, they get flattened upon hammering. But the non-metals, they do not get flattened upon hammering, but they break. Alright, so from here we can conclude that metals are malleable, whereas non-metals are brittle. So basically we got to know that all the metals, they are malleable, whereas non-metals, they are brittle. Okay, so the non-metal was here the graphite. So non-metal graphite, it is brittle. That means it cannot be flattened upon hammering. Alright. Okay guys, now let us see few questions. See question number 1. What is malleability? Name the most malleable metals. Now we know that malleability, basically it is a property by virtue of which the metals, it can be beaten into thin sheets or foils. So that property is known as malleability. Now the most malleable metals are either gold or silver. Alright. Now let us see the second question. Have you ever seen a blacksmith beating the iron piece? Do you find a change in the shape of these pieces on beating? Would you expect a similar change in woodlock on beating? So your first question says that have you ever seen a blacksmith beating the iron nail? Yes, definitely most of you have seen that a blacksmith beating the iron piece, right? So second question, it is asking that do you find a change in the shape of these pieces on beating? Yes, of course, we have seen that the shape of the iron, it changes upon beating. So because we can say that it changes on beating because iron, which is a metal, and metal, they have the property of malleability. So this is why we can see the change in the shape of the iron pieces on beating. Alright. Now last question you are being asked, would you expect a similar change in woodlock on beating? Definitely not. So because we can say that woodlock, which is not a metal, and thus it does not have the property of malleability. So on beating the woodlock, it will simply break because it is a non-metal, and non-metals, they are brittle. They do not have the property of malleability. Clear everyone? Okay guys, now in this module we will see the other properties of physical properties of metals and non-metals, the color, hardness and ductility. Now let us see the color of non-metals. So non-metals are colorless while some are colored. Now most of the non-metals, they are colorless, but while some of them are colored. So as you can see, chlorine, it is a greenish yellow gas. So this chlorine, it is a gas which appears to be greenish yellow. So bromine is a brown liquid. Okay, bromine appears to be a brown liquid. Iodine, so iodine is a violet solid. So the physical property of this iodine, it appears to be a violet solid. And nitrogen is a colorless gas. Okay. Now let us see the other physical property, that is hardness. So most metals, they are hard. Now most of the metals, they are hard. So from here you can see that the metals like sodium and potassium are so soft that they can be cut with a knife. Now most of the metals, they are hard, but the other metals like sodium and potassium, they are soft, and thus they can be cut with a knife. Alright, as you can see here. Now if we talk about the non-metals, so basically the non-metals, they are generally soft. Alright, but there is an exception. So diamond is an exception. It is the hardest substance known. Now diamond, it is the hardest substance known. So even though it is a non-metal, but it is an exception, and it is the hardest substance. Okay guys, now let us see ductility. So most metals can can easily be drawn into thin wires which have a wide range of applications. The property by virtue of which metals can be drawn into thin wires is called ductility. Okay guys, now see, ductility is a property by which most of the metals, they can be easily drawn into thin wires. Can you see here? So those metals which can be easily drawn into thin wires, that property is called ductility, and they have a wide range of applications. Gold and silver are two of the most ductile metals known. So the two most ductile metals known are gold and silver. They have the property of ductility because these two metals, they can be easily drawn into thin wires. Can you see here? Alright. Other metals that can be drawn into wires include copper, aluminium and tungsten. Now apart from gold and silver, some other metals are also there which can be drawn into thin wires. They include copper, aluminium and tungsten. So see, this is an example of copper wire, and this is an example of aluminium wire, and these are the examples of a tungsten wire. Clear everyone? Okay guys, now I have one question for you all. Have you seen wires of coal? Definitely not. We have not seen wires of coal. Non-metals are brittle and cannot be drawn into wires. Now see, coal, it is a non-metal. So non-metals, they are brittle and thus they cannot be drawn into wires. So from here we can conclude that non-metals, they do not have the property of ductility because they are brittle. Alright. Okay, now again I have one question for you. Name the property of the metals by virtue of which it can be drawn into wires. So guys, now can you tell me who is property of the metal by virtue of which it can be drawn into wires? Yes, definitely, the property is called ductility. So it is the property in which the metals can be drawn into wires. Now see the last question. Name the two metals which can be cut with a knife. So the two metals which can be cut with a knife are, so can you tell me what are the two metals? Yes, they are sodium and potassium. So they can be cut with a knife. Okay guys, so we are done for this lesson number 2, and we will again continue the other physical properties of metals and non-metals in our next lecture. Thank you and keep on studying.